All right, so we're going to be looking at functions versus relations. Functions versus relations, okay? Now, we're not going to do everything necessarily that's in this set of notes, but use it for the purposes that we need. Now, when we're talking about a function versus relation, the first thing we want to talk about is what is a relation, okay? It says a relation is a set of inputs and outputs often written as ordered pairs, okay? Ordered pairs. So go back to your middle school days. When we're talking about an ordered pair, remember we're talking about like an X and a Y. Okay, for instance, if I had an ordered pair, maybe it's like 1, 2. Okay, the first one is always our X, and the second one is always our Y, and that would be a point that we could plot on a graph. For instance, if I look at this guy here, 1, 2 would be 1 over on the X and up 2 on the Y. So this point right there, that would be the point 1, 2, where 1 is our X, 2 is our Y. Okay, so remember, that's how we plot a point. Or if I wanted to plot the point, let's say maybe 0, -2. Actually, let's use a different color here. If I wanted to plot the point 0, -2, that would be 0 on the X. In other words, it doesn't move anywhere. It's not going left or right. And then -2 would be down 2 on the Y-axis, down 2 on the Y-axis. So this point right here would be 0, -2, okay? So that's just a quick review on how to plot points, but that's what we need when we're talking about a relation here. That's what we need when we're talking about a relation, okay? Is that it pairs up some input, some output, X and Y, and it can be represented in different ways. It could be represented as a mapping, okay? So this guy right here would be a mapping. Sometimes it could be represented as a table. Sometimes it could be represented as a set of points on a graph, just like we saw there a second ago, okay? But a relation pairs an input X with an output Y, okay? So whether we're talking about input or we're talking about output, whether we're talking about X and Y, those names can be used interchangeably. And then also in one of the videos, we'll talk about domain and range, but at the moment, I just want to focus on input X and output Y. Okay, now this guy is a mapping, and all it does is it shows us what goes with what. So my X of 0 is being mapped to my -2. So X0 is mapped to the output Y, -2. Okay, now we could think of that as a point. Okay, we could think of that as a point 0 for my X, -2 for my Y. And then as a point, we could plot this on the graph. 0, -2, well, 0, -2 doesn't move on the X, but it goes down 2 on the Y. So it would be plotted right there. That would be the point 0, -2. Okay? Then we could think of the next pairing. 0 is also mapped to 1. 0, 1. Okay? So that would go 0 on the X. It's not going anywhere on the X, but it goes up 1 on the Y. So this guy right here, there we go. This would be 0, 1. This is 0, 1. Okay? Then also we have 1 is going to 2. So the input X is mapped to the output Y, 2. So then we have the point 1, 2. Well, that would go out 1 on the X and up 2 on the Y, so we'd end up here, right? So that guy right there, this guy right there, that would be 1, 2. Okay? Then we have 2, the input X going to 1. Okay? Well, that would be out 2 on the X, up 1 on the Y, so that point right there would be 2, 1. Okay? Then lastly here, that's not what I wanted. There we go. Okay. Then lastly, here we have 3 going to 4. So we have 3, 4. So 3 is paired with 4. So we're going out 3 on the X. 1, 2, 3. And then up 4 on the Y. 1, 2, 3, 4. So this point right there, that would be 3, 4. Okay. So that's a couple different ways that we can represent a relation. Input X, output Y on a mapping. We can represent them as points. We can represent them as points on a graph. And then lastly, we could also represent them as a table, okay, where we have X, our input, and then we have Y, our output. We could represent it as a table. So all the X's would go in the input. So notice my x values, the same x values that we have over there. Oh, what did I do over here? Let's see. We had 1, 2, 2. I forgot a whole point over here. That's my bad, guys. I forgot to write a point over here. So we had 2, 1. That was this guy over here. Okay, there we go. Now we have everything. So looking at this, the inputs would be the same. I have an input of a 0 and an output of a -2. I have an input of a 0 and an output of 1. I have an input of 1 and an output of 2. And then I'm going to go to this guy because it'd be next chronologically there. So we have an input of a 2 and an output of a 1. Then we have an input of a 3 and an output of a 4. Okay, so all of these represent the same exact relation in different ways. A mapping, a set of points, points on a graph, and then that guy would be a table. Okay, now that's what a relation is. A function is a specific type of relation. Okay, so it's a relation, but it's a relation in which each input x, they say domain, and we'll talk about that later, each input x has only one output y. So it's a specific type of relation in which if I plug in an x, I only get one y. There's only one y that goes with it. A good way to think of it is x cannot repeat. So when we're looking at these different examples, x cannot repeat. Well, let's go back to this example over here, okay? Do any of my x values repeat over here? Well, yeah, 0 is going to -2 and 0 is going to 1. It repeats. 0 repeats. Not a function. Does 0 repeat in my points? Yes, I have 2 zeros here. Not a function. Does 0 repeat on my graph? Yeah, if we look at the x value of 0, that would be this guy over here. Okay, it's on the y-axis essentially. Notice 0 repeats there. I have a 0, 1, and I have a 0, -2. Not a function. Does 0 repeat on my table? Yes, right here. If it repeats in the x, not a function. Is it okay to repeat for the y's though? Yes, and we'll see that here in a second. Okay, so let's look at this guy over here. Okay, so again, this guy right here, let's see if this is a function. So we have a -1 going to 2. So one of my points is a -1, 2. Okay. Now, they also plot that over here, but I'm going to get to that in a second. Let's just finish writing our points here. Okay. Then we have 0 going to 2. So 0 is also going to 2. So notice we have a repeat in the y's, and we'll see if that's okay or not. Okay. Then we have 1 going to -3. Then we have 2 going to a -2. And then we have 8 being paired with 3. Okay, so that's what we see so far. So all I did was rewrite it as a set of points. So this is our mapping over here, x going to our y's, and this guy is a set of points. Now let's plot our points, okay? And I just want you to be able to see the different representations. So all of these that we're going to be doing here represent the exact same thing, but I just want you to see the representation. So a -1, 2, well, that would be out a -1 on the x and up 2 on the y. So this guy right there, that would be our -1, 2. Okay? Then 0, 2. Okay, 0, 2 would be 0 on the x, up 2 on the y. So that guy there. Then we have 1, -3. That would be 1 out on the x, down 3 on the y. So we're there. Then we have 2, -2, be out 2 on the x, down 2 on the y. So that would be there. And then 8, -3 would be 8 out, 8 units on the x, up 3 on the y. So right there. Okay, so far, these all represent the exact same thing. Our mapping, our points, and our graph. I also want to show you the table, though. So remember, we could also represent this as a table where we have x as the input, y as the output. Well, in the first one, we have a -2 being paired with, or -1 being paired with 2, 0 being paired with 2, 1 with a -3, 2 with a -2, and 8 with 3. Okay, so all of these represent the exact same relation that we're talking about now. Now, what we want to decide, is it a function? Remember, a function, each x can only have one y. In other words, if we see an x repeat, it is not a function. Well, let's look at this. Are there any x's repeating in my mapping? No. Each one of these only have one line attached to it. As long as these have one line, we're okay. But you might say, well, Mr. Pinksterhouse, doesn't 2 have 2 lines going to it? Yes. It's okay if y repeats. Y can repeat, x cannot. Okay, so in this case, this would be a function. This mapping would be a function. Now let's check our points. Make sure we can see the same thing. Do any of these x's repeat? No. So this would be a function. Each x is only going to one y. Okay? Now you might say, well, Mr. Pinksterhouse, don't these y's repeat? Yes, but this x, -1, goes to 2. That's one y. This 0x goes to 2. That's only one y attached to it. Y's can repeat, x cannot. Okay? Then you see the same thing on our graph here. So notice, if I look at each one of these, each x is only going to one y. And then same thing here. There's no repeat in x, so we're okay there. So these guys would be a function. Okay? This would be a function. Okay? Now, I'm going to skip all the way down to here, and let's just work on a couple of these examples real quick, and then we'll get some more practice tomorrow. So if I look at this first one here, they say domain, okay? Here's what you guys got to remember about domain and range. Domain is the x, the input. Range is our y, the output. Okay, so you can use all three of those words essentially interchangeably. So what they're really saying here is this is my x, this is my y. Well, this is a mapping. Does each x only go to one y here? Yeah. In other words, do the x's repeat? No. So this would be a function. The x's do not repeat, so this would be a function. Okay, what about this one? Does each x here go to one y? In this case, no. This x is going to two different y's, okay? So x repeats here. This x is being paired up with two different y's. Remember, the definition of a function is for each x, there's only one y. So for each x, each input x, there has to be only one y. Now I have two y's. That is not a function. This is just a relation, okay? Or you could say not a function, okay? Now this one, this is a table. How can I tell if it's a function or not? Well, do any x's repeat here? No. So this would be a function. X's do not repeat. Each x is only paired with one y. We have a function there. Okay. Now, last thing I want to look at, they do talk about domain and range. We'll talk about that here in a second, but what I really want to do right now is just plot these points and be able to tell if it's a function or not a function. So let's plot this point here. Let's plot it in red, okay? So 2, -3, well, that would be over 2 on the x, down 3 on the y, so we're going out here, down 3, so we'd end up over there, okay? So 2, -3, then we have 2, 4, 2, 4, out 2, and up 4, 1, 2, 3, 4. And then the last one here, we have 2, -1. Well, that'd be out 2 on the x, down 1 on the y. Well, look at this guy. Notice, does my x repeat here? Yes, okay. The x value of 2 is paired up with 4. It's paired up with a -1, and it's paired up with a -3. My x's are repeating. So is this a function? No, it's a relation. It's not a function, it's a relation because the x values repeat. Now, when they talk about domain and range, okay, here's what you need to know. Domain is the x, all the x's. Range is all the y's. So when it asks us to state the domain and range, this is what it really means. The domain, we can say D for domain, is all the x's that are here. Well, what are all the x's here? Just the 2, right? So we would say my domain just consists of 2 here. The range is all the y's. Well, what are all the y's that I have here? -3, 4, and -1. So my y's, if we're going from least to greatest, would be -3, -1, and 4. Okay, that would be the domain and range. So it's not adding much to it. It's just if they ask you for the domain and range, that's what it is. Let's try one more together here. So notice I have this guy, 2, 6. So if I plot 2, 6, I'm out 2 on the x, up 6 on the y. 1, 2, 3, 4, 5, 6. Double check that. 1, 2, 3, 4, 5. Oh, messed up there. Lost my count there. All right, out 2 on the x, up 6 on the y. 1, 2, 3, 4, 5, 6. There we go. That's better. Okay, so that's that first point. Then we have 6, 2. So we're out 6 on the x. 1, 2, 3, 4, 5, 6. And up 2 on the y. 1, 2. So those would be my 2 points. Now, do the x's repeat here? No. I have a 2 and a 6. They do not repeat. This would be a function. Now, if we want to write the domain and range, okay, the domain is just the x values. So in our set, all we have to do is list all the x's. Well, what are the x? 2 and 6. So 2 and 6. That's it. If I want to list the range, I just need to list the range as the possible y values. Well, that would be 6 and 2. I like to go from least to greatest, so I'm going to put 2 and 6. Okay? That would be our domain and range, or the input and the output, the x and the y. Okay?